Hello everyone, welcome to the Equation Web. Today we'll be doing an arithmetic problem, so let's start with the question. Today's question will focus on the floor function, and this is a special function that will be explained more further into the video. So today's question is, find all positive real numbers x such that the following arithmetic condition is met. X cubed minus the floor of x is equal to 3. So I'll give you guys some time to try and solve this question and try to get the answer to it. So the floor function is a special function where all the numbers that are put into the floor function are always rounded down. They're never rounded up. So for example, let's say we take 2.2. Normally this would round to 2, and it also rounds to 2 in this case. The same goes with 2.3, but here's a special case. If we take 2.99, it makes it equal to 2, which means that it rounded it down instead of up to 3. So we can describe this as an inequality. So we can say that the floor of x is greater than x minus 1, but it can also be less than or equal to x. This basically tells us that the number that we plug into the floor function, it is always going to be greater than 1 minus that number, but it can also be equal to that number, or it can be less than it. So our original function, it involved x cubed. So let's do x cubed minus every single term. So we get that x cubed minus x is less than or equal to x cubed minus the floor of x is less than x cubed minus x minus 1. And we know that x cubed minus floor of x is equal to 3, so we can plug that in to get our final result of x cubed minus x is less than or equal to 3 is less than x cubed minus x plus 1. Now that we have that inequality, we can say that floor of x is equal to x cubed minus 3 by rearranging our original equation. So we can say that x cubed is equal to k. Now what you see on screen just means that k is an integer. The trident looking symbol is element of, and the z looking symbol just means the set of integers. So -1, -2, 0, 1, 2, 3, so on. So it just means k is an element of the set of integers. So now we can simplify that equation, and we get that x is equal to the cube root of k. And this implies that the floor of the cube root of k is equal to k minus 3. We get this from the rearranged equation we made a little bit ago. Now we need a solution to this equation. So let's plug in values of k until we find the solution. First, we plug in 5. The cube root of 5 floored is equal to 1. If we plug in 5 into k minus 3, we get that 5 minus 3 is equal to 2, and 1 is not equal to 2, meaning this is not a solution. K is equal to 4, so we get the cube root of 4 floored, which means that we get 1, and 4 minus 3 is 1, and 1 is equal to 1, which means that x is equal to cube root of 4 is one of our solutions. If we plug in 3, we get that the cube root of 3 is equal to 1 floored, and 3 minus 3 is equal to 0, and 1 is not equal to 0, meaning this is not one of our solutions. So one way we know that we don't have to plug in any more numbers is that when k is greater than 5, k minus 3 is greater than the cube root of k, which means that x is equal to cube root of 4 is our only solution, as that is less than 5, and it satisfies our equation. So our question was, find all positive real numbers x such that the following arithmetic condition is met. X cubed minus the floor of x is equal to 3. We just got that the solution is equal to the cube root of 4. Thank you for watching, and make sure to like and subscribe.